Power or problem? Have you ever thought about something super, super tiny? Something so small it's almost invisible? And what if I told you that splitting this tiny thing could power an entire city? Wow, that sounds like science fiction, doesn't it? But it's real. We're talking about atoms, folks. These little guys pack a serious punch. When we tap into their energy, we can light up our world. We can run factories, power homes, and keep our gadgets charged. It's an incredible source of power, all hidden inside something you can't even see. Pretty amazing, right? But hold on a second. There's another side to this story. What if that same tiny thing, when split, could also cause massive destruction? That's the big question, isn't it? It's like having a superhero that can save the day, or, if things go wrong, cause a whole lot of trouble. This duality, this power for good or for bad, makes understanding atoms so incredibly important. It's not just about cool science, it's about our planet and our future. We need to know what we're dealing with because the stakes are super high. So, what's the deal with these atoms? How can one tiny particle hold so much power and so much peril all at once? It all comes down to what's inside that atom, particularly its core, its heart. That's where the real action is, the place where the secrets of immense energy are locked away. Scientists have been working for decades, peeling back the layers, trying to understand these fundamental building blocks of our universe, and what they've found is truly mind-blowing. It's a journey into the very essence of matter. Are you ready to explore this? To dive into the world of the atom and uncover its secrets? I thought so. We're going to look at what makes an atom tick. We'll see how we can harness its energy for good, and we'll also talk about why we need to be super careful with it. It's a fascinating subject full of twists and turns. So, put on your thinking caps because we're about to go on an atomic adventure. Science is cool, and understanding the atom is one of the coolest things you can do. Okay, let's talk about atoms. What in the world is an atom? Imagine something so incredibly tiny, so unbelievably small, that millions and millions of them could fit on the very tip of a pin. Seriously, you can't see them with your eyes, not even with a regular microscope. You need super-duper powerful tools for that. These tiny, tiny particles are the basic building blocks of everything around us. Absolutely everything. The air you breathe, the water you drink, the chair you're sitting on, even you and me. We are all made of atoms. Think about it. Every single thing in the universe, from the smallest grain of sand to the biggest, brightest star in the sky, is made up of these fundamental pieces. They are the Lego bricks of reality, combining in countless ways to form all the different materials and substances we see and interact with every day. It's a pretty astounding idea, isn't it? That such complexity arises from these simple, tiny components. Nature is an amazing architect, using atoms to build the entire cosmos. It's like a giant cosmic construction set. Now let's peek inside an atom. What's in there? At the very center of every atom, there's something called the nucleus. Think of it as the atom's tiny, dense core, its command center. It's incredibly small, even compared to the atom itself. If an atom were the size of a giant sports stadium, the nucleus would be like a single marble sitting right in the middle of the field. But don't let its small size fool you. This nucleus is where most of the atom's mass, its stuff, is packed in. And what's inside this super tiny nucleus? Well, it's home to even smaller particles called protons and neutrons. Protons have a positive electrical charge. Think of them as the positive thinkers of the atom. Neutrons, on the other hand, have no charge. They're neutral, just chilling out. Zooming around outside the nucleus, in specific paths or shells, are other particles called electrons. Electrons are super tiny and have a negative electrical charge. So, you've got this busy little system. A dense core with electrons whizzing around it. It's a miniature solar system, right inside every bit of matter. So we have these atoms with their tiny packed nuclei. The science that studies these atomic hearts, these nuclei, is called nuclear physics. Now, nuclear physics might sound like a really complicated, brainy subject, something only people in white lab coats with crazy hair would understand. But at its core, pun intended, it's all about figuring out what's happening inside that nucleus. It's about the particles there, the protons and neutrons, and the incredible forces that hold them together. It's a deep dive into the atom's control room. Why is the nucleus such a big deal? Well, that tiny core holds an astonishing amount of energy. It's like a tightly coiled spring, just waiting for a chance to release its power. The forces at play inside the nucleus, called the strong nuclear force, are the strongest forces we know in the entire universe. They have to be, to keep all those positively charged protons crammed together when they'd normally want to push each other away. Understanding these forces is key to unlocking the atom's energy, for better or for worse. So why should you or anyone care about nuclear physics? Well, it's not just about abstract science. Understanding the nucleus helps us comprehend some of the biggest questions about our universe. Like, how do stars shine? That's right, the sun and all the stars are giant nuclear reactors. Nuclear physics also allows us to develop amazing technologies. We can create new forms of energy to power our world. We can develop medical treatments that save lives, like using radiation to fight cancer or to see inside the human body. And yes, it even has a role in rocket science. Some spacecraft use nuclear power sources for long journeys into deep space where sunlight is too weak for solar panels. So, nuclear physics is incredibly important. It touches so many parts of our lives, from the electricity we use, to the medical care we receive, to our understanding of the cosmos itself. It's a field of science that has truly changed the world and continues to shape our future. It's powerful stuff in every sense of the word. Ever heard of a chain reaction? It's a really cool concept. Imagine you have a long line of dominoes all standing up. You gently push the first domino. What happens? It falls and knocks over the next one, which knocks over the one after that, and so on, all the way down the line. Plink, 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 plink. That's a chain reaction. One small action starts a sequence of events, where each event triggers the next one, creating a cascade effect. It's a ripple that grows and spreads. You can see chain reactions in everyday life, not just with dominoes. Think about a rumor spreading through a school or an office. One person tells two friends. Then those two friends each tell two more friends, and before you know it, everyone is talking about it. That's a social chain reaction. Or think about a wildfire. A single spark can ignite a dry leaf, which sets a branch on fire, which then spreads to a whole tree, and soon a huge area is ablaze. One small start can lead to a very big result. Now let's bring this back to our friend, the atom, and specifically, nuclear physics. In the world of atoms, a chain reaction can happen when one tiny nuclear event, like the splitting of an atom's nucleus, releases particles that then cause other nearby atomic nuclei to split. And when those nuclei split, they release even more particles, which cause even more nuclei to split. It's like those dominoes, but instead of just falling over, each domino releases a burst of energy and more pushers to knock over other dominoes. This kind of nuclear chain reaction is super important because it's the key to releasing a massive amount of energy very quickly. If you can control it, you can generate a steady stream of power. If it happens too fast, uncontrollably, well, that's when things can get explosive. So understanding and managing chain reactions is absolutely crucial when we're dealing with nuclear energy. It's all about careful control of that first push and the dominoes that follow. It's a delicate, powerful dance of particles. Alright, science fans, let's talk about one of the most famous processes in nuclear physics, nuclear fission. Fission is just a fancy science word that means splitting apart. So, nuclear fission is all about splitting an atom's nucleus. Not just any atom, though. We usually use heavy atoms like certain kinds of uranium or plutonium because their nuclei are big and a bit wobbly, making them easier to split. Think of it like trying to split a giant log with an axe. It takes effort, but when it splits, it really splits. How do we make this split happen? Well, scientists don't use a tiny atomic axe. Instead, they shoot a tiny particle, usually a neutron, at the nucleus of one of these heavy atoms. If the neutron hits the nucleus just right, bam! The nucleus becomes unstable and splits into two or more smaller nuclei. It's like throwing a small pebble at a big, precariously balanced rock. The pebble can trigger the whole thing to break apart. This splitting process is the heart of nuclear fission. Now here's the really exciting part. When that heavy nucleus splits, it doesn't just break into smaller pieces. It also releases a tremendous amount of energy. Far more energy than you'd get from a chemical reaction, like burning wood or gasoline. And very importantly, it also releases a few extra neutrons. These new neutrons can then go on to hit other nearby heavy nuclei, causing them to split, releasing more energy and more neutrons and so on. See? It's that chain reaction we talked about. It's fission causing more fission. And just a quick peek at another nuclear process, nuclear fusion. If fission is about splitting atoms, fusion is the opposite. It's about joining them together. This usually involves very light atoms like hydrogen, squishing together under incredible heat and pressure to form a heavier atom, like helium. This is what powers our sun and all the stars. Fusion releases even more energy than fission, and it doesn't produce the same kind of long-lived radioactive waste. Scientists are working hard to make fusion power a reality on Earth. It's a huge challenge, but the payoff could be enormous. So we've split some atoms, we've got this amazing fission process releasing tons of energy. That's cool science. But how does it actually help you bake a pizza or watch your favorite science show on TV? How do we turn that atomic energy into electricity that powers our homes and cities? Well, it might sound complicated, but the basic idea is surprisingly similar to how we generate electricity from burning coal or natural gas. The key difference is what we use to create the heat. In a nuclear power plant, the star of the show is the nuclear reactor. Inside the reactor, we have fuel rods, usually containing uranium. This is where that controlled nuclear fission chain reaction happens. As the uranium atoms split, they release a huge amount of heat. This heat is the first big step. We're not directly using the split atoms themselves to power your lights, we're using the intense heat they generate. It's like having a super powerful, super hot furnace that doesn't burn anything in the usual sense. What do we do with all that heat? We use it to boil water. That's right, good old H2O. The heat from the reactor is transferred to water, turning it into very hot, high-pressure steam. It's basically a giant high-tech kettle. This steam is really important because it's what we use to get things moving. So we go from atomic splitting to heat to steam. This process of converting heat to steam is a common step in many types of power plants, not just nuclear ones. Now this powerful steam is directed at a machine called a turbine. A turbine has blades, kind of like a giant sophisticated pinwheel or a jet engine fan. As the high-pressure steam pushes past these blades, it makes the turbine spin around really, really fast. This spinning motion is what we're after. The turbine is connected by a shaft to another machine called a generator. As the turbine spins, the generator spins too, and through the magic of electromagnetism, it converts that spinning motion into electrical energy. And zap! Electricity flows out to the power lines and into your home, ready to power your pizza oven. Now we've talked a lot about the incredible power of the atom, how it can light up our cities. But it's super important to remember that this power comes with big responsibilities and potential dangers. It's not all sunshine and perfectly baked pizzas. There's a serious side we absolutely have to consider. One of the biggest challenges with nuclear fission power is the waste it produces. After the uranium fuel has been used in a reactor, it's still radioactive. And it can stay radioactive for a very, very long time, thousands, even hundreds of thousands of years. This nuclear waste needs to be handled and stored extremely carefully to make sure it doesn't harm people or the environment. Scientists and engineers have developed methods like storing it in special containers and burying it deep underground in stable geological formations. But finding and agreeing on permanent storage solutions is a complex issue that countries around the world are still working on. It's a long-term commitment, and we have to get it right. Protecting future generations from this waste is a huge ethical responsibility. Another concern is the risk of accidents at nuclear power plants. While modern reactors have many safety features, and the industry has learned a lot over the decades, accidents can still happen. Events like Chernobyl in 1986 and Fukushima in 2011 showed the world what can go wrong if there are design flaws, human errors, or extreme natural events. These accidents released radioactive materials into the environment, caused evacuations, and had long-lasting health and environmental consequences. They serve as stark reminders of the need for constant vigilance and the highest safety standards. And then, there's the most sobering use of nuclear physics, nuclear weapons. The same atomic splitting process, fission, that can generate electricity, can also be used to create bombs of immense destructive power. The chain reaction in a nuclear weapon is designed to happen incredibly fast, releasing a massive amount of energy all at once. The history of the 20th century, with the bombings of Hiroshima and Nagasaki, showed the horrific devastation these weapons can cause. The existence of nuclear arsenals remains one of the most serious global security challenges we face today. It's a powerful reminder that scientific knowledge can be a double-edged sword. Now you might be thinking, Bill, this nuclear physics stuff, fission, chain reactions, it sounds really complicated. Is it just for super smart scientists in big laboratories? And I'm here to tell you, absolutely not. Understanding the basics of atoms and nuclear energy isn't just for the PhD crowd. It's for everyone. It's for you, it's for me, it's for your friends and family. Knowing a little bit about this science can help us all make more informed decisions about our world and our future. Think about it. We all use energy every single day. When you flip a light switch, charge your phone, or ride a bus, you're using energy. And we, as a society, have to make choices about where that energy comes from. Do we use more fossil fuels? Do we invest in solar and wind? What role should nuclear power play? If you understand the basic science behind these options, including the pros and cons of nuclear energy, you're better equipped to participate in those important conversations. You can ask smarter questions and understand the answers better. It's not about becoming a nuclear physicist overnight. It's about grasping the fundamental ideas. For example, knowing that splitting an atom releases energy, but also creates waste that needs careful management, is a key piece of information. Understanding that a chain reaction can be controlled for power, or uncontrolled in a weapon, helps you see the different sides of the technology. This basic scientific literacy empowers you. It helps you see through hype or misinformation and focus on the facts. So don't be intimidated by the word nuclear. The concepts, when broken down, are understandable, and learning about them is actually pretty fascinating. It connects to so many things: how our universe works, how we power our society, how we approach big global challenges. Being curious, asking questions, and seeking out clear explanations, that's what science is all about. Having a grasp of basic atomic science is like having a secret decoder ring for understanding a big part of the modern world. It's empowering. So we've journeyed into the atom, explored its power, and acknowledged its perils. What does the future hold for nuclear energy? That's a really big question, and scientists and engineers all over the world are working on the answers. One major focus is on developing new types of nuclear reactors that are even safer and more efficient than the ones we have today. These are often called advanced reactors or next-generation reactors. Some designs aim to produce less waste or even burn up existing waste. Imagine that! Another incredibly exciting area is the ongoing quest for nuclear fusion power. Remember fusion? That's joining atoms together, like the sun does. It promises a huge energy payoff with no greenhouse gas emissions, and much less long-lived radioactive waste compared to fission. But creating and containing a mini-sun on Earth is an incredibly difficult scientific and engineering challenge. We're talking about temperatures hotter than the sun's core. Still, many brilliant minds are dedicated to cracking this nut, because if they succeed, it could revolutionize our energy future. As our world grapples with climate change and the need to reduce carbon emissions from burning fossil fuels, nuclear power is often part of the conversation. It's a low-carbon source of electricity, meaning it doesn't release those planet-warming gases when it generates power. So for some, it's seen as a crucial tool in the fight against global warming, providing reliable baseload power that can complement intermittent renewables like solar and wind. However, the concerns about waste and safety remain, so it's a complex debate with strong opinions on all sides. Ultimately, understanding atoms, their immense power, and the responsibilities that come with using it is more important than ever. Whether we're talking about new reactor designs, the dream of fusion, or the ongoing need to manage waste and prevent the spread of weapons, it all comes back to this fundamental science. So keep being curious. Keep learning about the world around you, from the tiniest particles to the biggest challenges we face. Because understanding science, especially the science of the atom, is vital for building a better, safer, and more sustainable future for everyone. Science rules.